Hi guys, in this video we are going to rationalize the denominator of a higher order surd, which is 1 over the cube root of 5 squared plus 2 times the cube root of 5 plus 3. So what we can say is let gamma be equal to the cube root of 5. So what we actually have here is gamma cubed minus 5 is equal to 0 if you cube both sides, and this expression now becomes 1 over gamma squared, because the cube root of 5 is gamma, plus 2 gamma plus 3. Now what we can say is set up two functions. Let a of x be equal to x cubed minus 5 and b of x be equal to x squared plus 2y plus 2x plus 3. So in order to rationalize this cubic surd, what we need to do is we need to use the Euclidean algorithm or to find the HCF or the GCD. So how do we find the HCF or the GCD of these two polynomial functions? So what we need to do is we need to take a of x and divide it by b of x. So if you take a of x and you divide it by b of x, what we actually getting is x cubed minus 5 over x squared plus 2x plus 3. I'm going to use detached coefficients or synthetic division. Well, there are many ways to do this. The method that I usually use and I find efficient is I detach the coefficients of all these, so I call it 1 0 0 minus 5. So 1x cubed minus 0x squared plus 0x minus 5, right? And x squared plus 2x plus 3, so 1 2 and 3 goes in here. So 1 can go into 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3. Now we subtract. If we subtract, we get minus 3 minus 2. Bring down the minus 5. Now 1 can go into minus 2 times. So what we have now here is minus 2 times 1 is minus 2. Minus 2 times 2 is minus 4. And minus 2 times 3 is minus 6. And if we subtract again, we end up with minus 3 plus 4, which is 1, minus 5 plus 6, which is 1. Therefore, the answer to this is the quotient is x minus 2, right, plus the remainder, which is x plus 1 over the divisor, which is x squared plus 2x plus 3. So let us neaten this up and write it as this implies x cubed minus 5 is equal to, by multiplying by x squared plus 2x plus 3, x cubed minus 5 is equal to x minus 2 into x squared plus 2x plus 3 plus x plus 1. So what we have now is we have quotient 1, divisor 1, and basically remainder 1. So what we do is now we carry on with this repetitive division. So what we do is we repeat this division process again. We take the divisor 1 and dividing by remainder 1. So this was basically step 1, so equation 1. Now step 2, what we're going to do is we're going to take x squared plus 2x plus 3, and we are going to divide it by x plus 1. So I'm going to do it in the side again. So obviously, right, so what we have here is 1, 2 and 3, and the 1 goes on the outside, so 1 can go into 1 time. 1 times 1 is 1, 1 times 1 is 1, right, and we subtract, so 2 minus 1 is 1, and bring down the 3. 1 can go into 1 times, so we just have 1. And if we subtract here, we end up with a remainder 2. So the answer to this is x plus 1 plus 2 over x plus 1. And neatening this up, we should get x squared plus 2x plus 3, which is equal to x plus 1 into x plus 1 plus 2. So we stop here, guys, because the Euclidean algorithm says we need to stop at the last non-zero positive remainder. So basically, you need to stop at the last non-zero remainder. In other words, the answer over here is 2, the answer to your HCF. So basically, HCF between the polynomial is basically equal to 2. That's what I'm trying to say. So what we can say now is that HCF is now equal to 2 between a of x and b of x. So we write 2. So what we know is that HCF is equal to 2. So represent 2 in terms of, so make 2 the subject of the formula. So we can say 2 is equal to x squared plus 2x plus 3 minus x plus 1 into x plus 1. Now this x plus 1 is a further expansion from equation 1. Now you can write this remainder in terms of equation 1. So it will become x cubed minus 5 minus x squared into basically quotient 1 divisor 1. So what we can say now is that this here is further equal to, this implies this is now equal to x squared plus 2x plus 3 minus x plus 1 into x cubed minus 5 subtract x minus 2 into x squared plus 2x plus 3. Now, which is now equal to so what we need to do now is that we need to separate our a of x and our b of x. So we can say this is 2 is equal to negative into x plus 1 into x cubed minus 5 subtract. So you are subtracting x plus 1 and you are distributing inside here, so minus x plus 1, so sorry, plus x plus 1 into x minus 2 into x squared plus 2x plus 3, and remember that we have another one over here, so we should have written it, alright, so plus x squared plus 2x plus 3. So what we have now is that 2 is equal to minus into x plus 1 into x cubed minus 5 plus, if we open these up, we will get x squared minus x minus 2 into x squared plus 2x plus 3, and if we factorize this as well, so we should, okay, so plus x squared plus 2x plus 3. Now let us factorize this and add a 1 inside here. So we got 2, which is equal to minus into x plus 1 into x cubed minus 5 plus x squared minus x. Remember there's a plus 1 here because we are factorizing x squared plus 2x plus 3, which is common to both. Could have done it here, but let's see, just missed it. So what we can do now is we can just factorize this in here. So we just need to add a plus 1. So minus 2 plus 1, so we'll get minus 1 into x squared plus 2x plus 3. So basically we have written the final remainder in terms of a of x and b of x. Now note that, remember we've got an x over here. We set up two functions a of x and b of x because of these, right? So remember, when we set up these functions, what we can say is let gamma be equal to x. That's what we should have said. Now since gamma is equal to x, this implies that since gamma is equal to x, this implies that gamma cubed minus 5 was equal to 0, right? Since gamma cubed minus 5 is equal to 0, therefore x cubed minus 5 is also equal to 0. Let's see if gamma cubed minus 5 was equal to 0. Yes, that's where we have it, right? Now coming back down here, since x cubed minus 5 is now equal to 0, this part falls off. This implies what we have now is 2 is equal to, remember this part is now 0. This part here is now equal to 0. So this part here falls off. So we have 2 is equal to gamma squared, because x is equal to gamma, minus, we are substituting the gamma back, minus 1 into gamma squared plus 2 gamma plus 3. This is the small gamma. The big gamma is written as, looks like a r. Okay, anyways, now remember our original function was y squared plus 2y plus 3. Y squared plus 2y plus 3, so, oh sorry, gamma squared plus 2 gamma plus 3. So what we can say is 2 over gamma squared minus gamma minus 1 is now equal to gamma squared plus 2 gamma plus 3. This implies if we flip the fraction, right, so this is over 1. So if we flip this fraction, we're going to get 1 over gamma squared plus 2 gamma plus 3, which is actually equal to gamma squared minus gamma minus 1. Should be gamma minus 1 over 2. So basically this, which was 1 over the cube root of 5 squared plus 2 cube root of 5 plus 3, which is actually now equal to cube root of 5 squared minus the cube root of 5 minus 1 over 2, which we have it rationalized. So basically, how we know whether if these two things are the same, these two values are the same, if you check it out on the calculator, we have cube root of 5 squared plus 2 times the cube root of 5 plus 3. This answer is basically 0,107. Let me take more decimals. 0,208, 0,208, 958, right? 958. And what is this here equal to? We need to type it out. So, right, so if we type the second part out, be back with you in a minute just by typing it out and showing it to you. Hi guys, welcome back. So what we can see is that I have typed out this rationalized form, and I've got 0 comma 1070 8958, which is basically exactly the same thing.